In this video, I'm going to show you how to do the closing the horizons calculations. So I've got your data and that was recorded out in the field. So we've got your stations, we've got your single angle, we've got your double angle, and we've got the average. Now that we've got the average, what we're going to do is we're going to come down. I used Excel just to help me out. We're going to add up all of these average angle values. And they should be 360, but you can see right here they are not. They're not 360. They're 360 degrees, 5 minutes, and 12 seconds. So the difference between 360 and 360 degrees, 5 minutes, and 12 seconds is an overage of 5 minutes and 12 seconds. Since we have 4 angles, I'm going to get a correction factor. So I'm going to divide that 5 minutes and 12 seconds by 4, which is 5 minutes and 12 seconds by 4, and I get 1 minute and 18 seconds. That's what I'm going to correct per angle. And I'm subtracting it from the average angle to get an adjusted average angle. So this is my adjusted average angle. So I subtract out 1 minute and 18 seconds from each one of these, and I come up with the adjusted values. And when I add these up, I get 360 degrees. If you add these columns up individually, you get 357, 178, and 120. Well, there's 60 seconds in a minute. So there's 2 times 60 here, so that takes 2 minutes into this column. Well, if I add 2 minutes into this column, it gives me 180. We know that there's 3 times 60 and 180, so that brings 3 minutes or 3 degrees into this column. And that gives me my 360. So now that I've got my adjusted angle, and that's basically what this says in the PowerPoint online, it goes through the steps to calculate this. We're going to move on to figuring out the information down here. Okay, so we're going to figure out the first thing you're going to figure out is your azimuths. So these are azimuths. Now, azimuths are from, if you look at this picture here, the values, the black numbers on the outside of the circle are azimuths, starting from 0 up here and going clockwise from 0, 90, 180, 270, 360. So when you're doing azimuths, you're going, okay, if I start at 0 in my first angle that's turned over here, and we're assuming that the new southwest is our new north. That's saying basically this direction now is north. So I'm going to look at the angles and I'm going to say, okay, if this is a 0 line right here, I'm going to say my first azimuth is 120, and then I'm going to add 34 and change, and I'm going to add 135 degrees, 58 minutes and 12 seconds basically, and then I'll add 68 degrees, 41 minutes and 7 seconds. So that's what I do over here. So I'm taking my very first 0, I'm going to expand this. I'm going to take my very first 0 minutes, or 0 angle, and then I'm going to add, the southeast is our new, the southeast is our new north. So I'm going to say this is 0 degrees. I'm going to turn this angle, and it's going to give me 68 as an azimuth. Okay, pretending down here, over here is my new north. So I'm just going to copy this. So this is my new north area. So everything is going to be off of this line. Okay, so my first azimuth to the, and all of these are backwards, sorry, southeast, southwest, northwest, northeast, and then southeast. Had a typo. So the southeast is my new north. Okay, so I go, if this is my north, I go 68 degrees. Okay, and then from 68 degrees plus 120 degrees gives me 189 degrees, 37 minutes, 6 seconds. And then I add the 34 to the 189, and I get 224 degrees, 1 minute and 48 seconds. When I add the 135 degrees, 58 minutes, 12 seconds to the 224 degrees, 1 minute, 48 seconds, I get back to 360. So I'm going full circle all the way around this new north line. All right. Now, that is to get my azimuths. To get my bearings, I now say, all right, if this is my new north, my first angle would be in the northeast quadrant. So all I'm doing is now rotating this. I'm going to create this, see if I can create this as a block. I'm just going to rotate this one, it's a lot easier. So basically I've said this is now my new north. If I take this on top of this, okay, this is now my new north. And you can see that if I move, oops, undo. If I move this over, this line here is now in the northeast quadrant. This line here is now in the southeast quadrant. This line here is in the southwest quadrant, and it goes back to the 0 degree line, which is my north line. So over here what I've done is I've said, okay, if this is my new north, I turn 68 degrees. 68 degrees is still in the northeast quadrant, okay? Now, the line here, let me move it back so you can see, the line here is now in the southeast quadrant. So I take 189 degrees, 37 minutes and 6 seconds, and I subtract 180 degrees because you can see when I hover, when I put this over here, this line right here is 180. So I'm just a little shy of 100, you know, turning that 180. I'm sorry, that picture's wrong. Whoops. It says it's 189 degrees. So this is actually rotated here. So this is actually in the southwest. It's 180. It's already past 180 degrees. It's 189 degrees. It's already past 180 degrees. So it's in the southwest, right? Now, the 224 is still in the southwest. So I take 180 degrees and subtract it from 224. Now, if the angle was, let's say, over here in 100, you know, on this, if the azimuth was 150, so if the azimuth was 150, you could see that it was in the southeast quadrant, and it would be about 30 degrees southeast. All right, so the azimuth that's 224 degrees, 1 minute and 48 seconds is in the southwest quadrant, and so I'm going to get a bearing. I'm going to just subtract 180 from the 224, and that gives me 44 degrees south, 44 degrees, 1 minute, 48 seconds west. All right, and then the last one goes back to all the way full circle to the northeast, saying it's 0 degrees, 0 minutes, or you can just say it's north, 0 degrees. So now for the law of cosines. The law of cosines says if this is A and these lines here are B and C, so I'm going to highlight these and I'm going to change those colors to green. And I'm going to change this one just so I can talk in colors so you can also see. All right, so if we've got line A, I'm sorry, if this is line A and we're trying to find that distance, then we're going to take the square root of the line, the distance B squared plus the distance C squared minus 2 times the distance of B and C times the cosine of the interior angle. All right, so I'm going to do this one here first. So basically it says, all right, so I've got the length of 73.175, I'm going to square it. I've got the length of 200.69, and I'm going to square it. I'm going to subtract 2 times the 73.75 times the 200.69 times the cosine of 68 degrees, 41 minutes, and 7 seconds. Make sure that your your angle on your calculator is in degrees, not in radians. I had a typo here. Let me fix this. So when I do the math of this, so if you look at this equation here, this is how I've written it. Now, if you're using Excel, then Excel actually, the cosine of a value is in radians. But I went ahead and changed it and put degrees in this. So you can see I've got the 73.175 squared plus 200.69 squared minus 2 times 73.75 times 200.69 times, and this is cosine of 68 degrees, 41 minutes, and 7 seconds. So the distance between the southeast down here, it's not north anymore, the southeast line and the southeast line and the southwest line is 189 or 186.9625 feet. So that's in feet. Now, I'll show you one more example. So if I'm looking from the southwest, this line here, to the northwest, this line here, I've got 200.69 and I've got 172.56. That is my B and C lengths in the equation. And the A of the angle interior is 120 degrees, 55 minutes, and 59 seconds. So if you look at the formula here, I go 200.69 squared times 172.56 squared minus 2 times 172.56 times 200.69 times, and this is cosine of 120 degrees, 55 minutes, and 59 seconds. Do all that math and then take the square root of it. This means take the square root of it. I forgot to say that here. So you're going to take the square root of this. Okay, so if you have problems doing it all in one piece, break it down. I used the Excel to do this. So I broke it down into pieces so you can do your math in sections. So I first did, okay, I take the 172.56 squared. I take the 200.69 and I square it. And then I take the 2 times 200.69 times 172.56 times the negative, the cosine of that angle. And then I just take the square root, using my calculator, of all those pieces, the first two added and the second one subtracted, in my calculator. So if you're having problems trying to write it all out in your calculator, break it down into pieces. All right? So if you have any more questions, just let me know. You're responsible for doing at least the next two.